So now that we know that in order to set up a game, we need these minimum 4 types of information under that acronym PUPPY, let's sort of begin to organize the types of games we can think of depending on what varied combinations of players, information, payoffs, actions we can think of. Because that will help us decide which kind of games we want to use as models for the situations we face. So one of the things to remember about game theory is that just because something is a game theory and it's mathematical doesn't mean it's right. You have to look carefully at whether the game setup matches the situation that you're trying to explain and the outcomes you're trying to explain. So, and there are very, very, very many types of games. And in fact, in the book with von Neumann and Morgenstern I had mentioned earlier, they go through quite a few number of games, and subsequently in the field of economics, there has been more and more and more varieties of games that people have been looking at and theorizing. So I'm just going to run down a few variants in terms of what we can do with game theory. Now, one of the first things we can do is we can make some decisions about the rules of the game. Is the game cooperative? Can players cooperate with each other? Or is the game a pure competition? So for example, if the game is pure competition, this is how market models are put together, right? All firms will all compete with each other, perfect competition. But what if you've got OPEC? What if you've got collusion? What if people come together in a political advocacy group or a pack in order to say, while we might compete as businesses, collectively as businesses, we are going to object to taxes. So there is cooperation as well as competition. And so the rules of the game in terms of actions that are allowable lets you know whether it's a cooperative game or a competitive game. And this is going to be important for households, as we will see when we come to the theory of the household later. There are also symmetric and non-symmetric games. A game is symmetric if the payoff matrix for a particular action is the same for each agent. Each time you take ace, that's so many points. Each time you take a king, that's so many points. Symmetric. It doesn't matter who does it. But sometimes games can be non-symmetric. So for example, if you've got multiplayer games, you can have a rule that says whoever is the team leader will get more points, and whoever is lower ranked or a team follower will get fewer points. Pokemon Go works like that. I like Pokemon Go. But they have all these rules that if you are the leader who took the Pokemon, you will get so many points. But if you are the follower and it was not your team that had the most strikes, you will get fewer points, and so on. This is going to be important in economics of gender, because we're going to start looking whether the payoff matrix for an action, such as going to work, is the same for men and women. Is it symmetric that men and women get the same wages? In which case it's a symmetric payoff matrix. Or is there a wage gap? In which case hours of working is resulting in a very different payoff for the men and the women. So we're going to have to look at that. Is it a zero-sum game? A zero-sum game is a game where my gain is your loss, your gain is my loss. That's it. Total points is whatever it is, and we have to divide that pie up among us. But positive sum games mean that when we interact, the total volume of points is actually dependent on the actions of the agents. And most economic models of growth or production are actually positive sum games. The idea is that if you do comparative advantage, the total size of the pie goes up. It's not a zero-sum game. We're going to look at that. We're also going to look at whether the rules entail simultaneous or sequential. So this is going to be important in terms of something that we'll sometimes call first mover advantage. When we come to marriage models, we're going to see that if, for example, we say that decision making about education is sequential, we'll let our boy get educated first. Then we will educate the girls. So we're not against girls' education. We totally are for it. Just wait in line. Take your turn. Sequential. Right? So that's going to have a different outcome rather than if the decision was simultaneous in certain factors, that the girl has the right to ask for education same time as the boy. Right? So this is just metaphorical. But you can begin to see that there are very many places you can use this idea of sequential. Who gets to move first? Action A, action B, action A, action B. Who is doing the action? Who is doing the reaction? As compared to people go at the same time. We also need to think about perfect versus imperfect information. If the information is available equally to everyone, that's one kind of result. If it's not equally available to everyone, that's another kind of result. And, you know, we often talk about this in terms of education. Do people have equal access to education? Because that means then we are operating in a society where everybody has the same information base. But it's more complicated than that. What if there's a cultural norm in the United States that says it's actually kind of rude to ask people what their salary is? You don't go around asking people, hey, how much you earn? Which means you may never know if your male co-worker is being paid more than you. Imperfect information. You lack the information to even know whether your right has been violated. So you would need some alternate information bases to get that. The other element of games is, are they, you know, discrete or continuous? Are they repeated games or are they one-shot games? So, you know, dating app, that's a one-shot game, right? Swipe left, swipe right, I'm done. But if you're thinking of family, that's a long-term game. There's repeated actions. There's decisions about children. There's decisions about jobs. There's decisions about school. And decision A in year 1 is going to affect decision B in year 2, is going to affect decision C in year 3, and so on. So game theory suggests that when you are doing long-term strategy, you need to start thinking differently than if it's just, I don't know, one game, one fling, done. And finally, though by no means the only, right now we're going to work with competitive games because there's only so much I can do in this class. But most particularly, I'm not going to allow income pooling. But some games allow pooling. So in some games, for example, voting games, I might turn over my endorsements and my electoral pool to someone else when I decide to quit a race. That's one way to do it. If I'm in a family, I can pool some of my income, right? I can share my income with family members. Or sometimes we keep it discreet. You know, this is for me and this is for my brother, and okay, I'll contribute to the family, but no, I got my income and you got yours. We're not doing pooling income. So every one of these entails a different kind of PAPI. Number of players, number of actions, types of actions, the kinds of payoffs for those actions, the kind of information you have on the rules of the game, how the game is set up. And so depending on how I set up the game, that's going to show me whether my model is applicable or not. So a word of caution, now that I've noticed that there are types of games, what that means is, as a class of possible models, game theory is quite powerful. But any individual game, its results basically depend on my assumptions, how I have set up my rules of the game. So never confuse the fact that something is mathematical with it being correct. You always are going to have to check what rules is it prioritizing, what's hypervisible, what things is it not even including in our discussion of the rules of the game and who has what kind of information, what is invisible, how is it counting payoffs, is it making sure the payoff matrix is fair to everyone, how is it making assumptions about which actions should result in what rewards, what is it assuming about cooperation versus conflict. Every one of those is an assumption, and you're going to have to check that assumption against your data, which you can collect both mathematically as a quantitative thing, like in the American Time Use Survey, or ethnographically and sociologically by doing qualitative observations. And combining those, you have something that needs explanation, a set of behaviors, actions that help you understand what actions and what payoffs put in your PAPI when you're setting up your game. Then, and only then, do you have game theory as a useful mathematical model. That said, when you do that, it's very useful. So what we're going to do next is we're going to watch how economists, particularly feminist economists working on the field of economics of gender, have adapted game theory in order to give a better model of households, an alternative model of households compared to Gary Becker.